Hello there, Mr. Sutton here with the IM3 2-1 Extra Practice Number 1 solutions on operations with polynomials, specifically multiplying polynomials. For this one, to simplify, we have to distribute negative 4/3 m, which is to say multiply it, to everything in this parentheses. So going from left to right, negative 4/3 m times 8m squared. Let's take care of the coefficients first. This is going to be negative 4/3 times 8 over 1. So that's negative 32 over 3. And then m times m squared is going to be m cubed because we're adding the exponents of 1, invisible 1 there, and 2. Next, negative 4/3 m times negative 2/3 m. That's going to be positive 8/9 m squared. And then finally, negative 4/3 m times negative 31/8. This is going to be, well, let's see here. The 8 and the 4 can reduce a little bit so that we basically have 1/3 times 31 over 2. So that's going to be, let's see here, 31 over 6 positive, and we'll have an m to go along there from the term that we distributed. So 31 over 6m. To simplify this problem, we will start by distributing these numbers outside the parentheses to the numbers inside the parentheses, since we have multiplication on the outside and addition or subtraction on the inside. So we've got negative 7 times 9 giving me negative 63. Negative 7 times 6x, that's going to be negative 42x. And then over here, this 7 gets distributed, so we have 7 times 9x, which is 63x positive. And then 7 times 3 gives us positive 21. Combining like terms, we have negative 42x and a 63x. That's 21x. And we have negative 63 plus 21, giving us negative 42 for the constant. For this problem, we need to multiply these together. So I'm going to have to use FOIL, which is to say I have to distribute each thing in this first parentheses to each thing in the second. So we have negative 7a times a and negative 4. Negative 7a times a, that's going to be negative 7a squared, just using our exponent rules. We have exponent of 1 plus 1. And then negative 7a times negative 4, that's positive 28a. Now we have 3 being distributed, so 3 times a is 3a. And these last terms here, 3 times negative 4, it's going to give me negative 12. Now I'm going to combine like terms, 28a plus 3a, I can add those together to get 31a in the middle. And nothing else is going to change. For this problem, we're going to simplify by multiplying. So we're going to use FOIL, or distributing each thing in the first parentheses to each thing in the second. So we have p times p, our first terms, giving us p squared. And then the outer terms, p times negative 4 is negative 4p. Now the inner terms, we have 6 times p. 6 is getting distributed to the whole second parentheses. So 6 times p is plus 6p. And then 6 times negative 4, we've got negative 24. So that's going to be p squared, and combining like terms, we've got 2p in the middle, and then negative 24. To simplify this one, we're going to distribute each thing in the first to each thing in the second parentheses. So we've got negative 5x times 5x, that's negative 25x squared. And this is basically using FOIL, first, outer, inner, last. So we got negative 5x times negative 2, that's positive 10x. And then 2 times 5x is positive 10x again. Got it in a different way, though. And then our last terms, 2 times negative 2 is negative 4. So we've got negative 25x squared, plus, now in the middle we can combine these to 20x, and then we still have that minus 4 on the end. For this one, we're multiplying these together to simplify, and we can use either FOIL or just double distributive here, distributing the 8v and the 2 to the 6v and the minus 7. So we've got 8v times 6v, that gives us 48v squared. 8v times negative 7, that's negative 56v. And now the 2 gets distributed to each of these. So 2 times 6v is positive 12v. 2 times negative 7 is negative 14. And now combining like terms, we still have a 48v squared. But then these middle terms can get combined. Negative 56v plus 12v is going to be negative 44v, and then we still have the minus 14. To simplify this one, we're going to do some multiplying. We actually have 3 things getting multiplied. This 4, this n minus 1 parentheses, and this other parentheses. The key on this is to only multiply 2 of these together at a time. instead of trying to distribute 4 to everything, because that's actually going to be overusing the 4. So let me just start by distributing 4 to the first parentheses. That gives me 4n minus 4 in that parentheses. And now I'm going to multiply just these two parentheses together using FOIL, or just basically distributing 4n and negative 4 to each thing in the second parentheses. So we have 4n times negative 8n. That's negative 32n squared. And then 4n times 4 is going to be 16, positive 16n. Minus 4 times negative 8n, that's positive 32n. And then finally, negative 4 times positive 4 is negative 16. Combining like terms, we have negative 32n squared. This will be positive 48n, and then we have a minus 16. For this problem, to simplify, we have to multiply these parentheses. And one way to do this, we're basically distributing the negative 5x and the negative 6 to that whole second parentheses. So as kind of an optional step, just to remind me of what I'm doing, I've got negative 5x times that whole second parentheses minus 6 times, again, that whole second parentheses. So there's really 6 multiplications going on. At this point, I'm just distributing to each of these parentheses. So I have negative 5x times negative 5x squared. That'll be positive 25x to the 1 plus 2, so x to the third. And then negative 5x times negative 3x, that's positive 15x squared. Negative 5x times negative 8, positive 40x. And now we distribute the negative 6. Negative 6 times negative 5x squared, that's positive 30x squared. Negative 6 times negative 3x is going to be 18x. And then finally, negative 6 times negative 8 is positive 48. All right, at this time we combine like terms. So we have this 25x cubed. There's no other x cubed, so we'll just carry that down. 15x squared can get combined with the other x squared here, the 30x squared. So that's 45x squared. And then 40x and 18x can get combined because they both have x to the first. So that's 58x. And then finally, this 48 just gets carried down because there's nothing to combine it with. And that is our final answer. On this problem, we have a figure with some expressions that represent some dimensions. And we basically want to figure out an expression representing the area in square units of this figure. So this is kind of a weird shape, thinking about this geometrically. There's no formula for getting the area of an L. What we're going to have to do is chop this up into 2 rectangles. And there's a few different ways you could do it. I'm actually going to chop it this way. And so now I've got 2 different areas I'm calculating. So I have the area of this top rectangle. Now the area of a single rectangle in general is going to be base times height, or height times base. So to get the area of just this top rectangle, I have to multiply 4 and 4x plus 3 together. And I'll put that 4x plus 3 in a parentheses. So this is all going to represent area. But I also have to add to that the area of the smaller rectangle down here. So we have a base of 3x plus 1. And how about the height? Well, the height is whatever's left over from this 6 here after I've used up this 4 to get the top rectangle. So that's actually a height down here of 6 minus 4, or 2. So I can write 2 times 3x plus 1. And at this point, I'm just simplifying and combining like terms. So I can distribute before I combine anything. 4 distributed here gives us 16x plus 12. And then distributing the 2, this is going to be plus 6x plus 2. Combining up more like terms here, we've got a 16x and a 6x giving me 22x. And then 12 plus 2 is 14. So that ends up being, let's see here, answer choice D. For this kind of wacky problem, we have this weird equation, 2x minus b and 7x plus b equals 14x squared minus cx minus 16, true for all values of x, and they're telling us b and c are constants, and b is positive. Based on this, we want the value of c. All right, so really the only way to do this is to simplify the left side of the equation and try to write it in this form over here, and hopefully that should give us some insight on what b and c are, and based off of that we ought to be able to get the answer. So let me start by foiling out the left side here, distributing the 2x and the minus b to the 7x and the plus b. So we have 2x times 7x, that's going to be 14x squared, and 2x times b is going to be positive 2xb. And then we have negative b getting distributed, so negative b times 7x is negative 7bx. And then finally, negative b times b is negative b squared. And I can combine these middle terms here to get, let's see here, this is going to be, we have both, these are both at bx terms here, so we just add the coefficients and keep the variables. So this is negative 5bx in the middle. All right, so we can see here that in order to get c, we have to know the value of 5b, because those two things are equivalent. Well, what's b? If this and this are equivalent, that means all this stuff is equivalent to all this stuff, which is to say b squared and 16 must be, no pun intended, the same thing. So if b squared is 16, to actually get the value of b, I just have to square root both sides. Now, normally I would get a plus or minus, but they told us that b is positive. So this is just going to be b equals 4. And we said earlier that c and negative 5b, since they're both next to that x to the first power, they must have the same value. Since c is 5b, c is really 5 times 4, which is to say c must be 20, which gives us choice B, ironically.